So lesson 1.2 is functions and their properties. What I'm calling part 1 or day 1 is front and back of this first page, and it is all about knowing whether or not something is a function and talking the biggies are domain and range. Okay, so being able to look and decide, okay, what's the domain of this function? What's the range? So that's what we're going to spend today and probably into tomorrow on, is talking about domain and range. Okay? So, let's start and review function. What do you guys remember about whether or not something's a function? No? Don't remember much about a function? Well, if you look up in the official definition, a function from a set D to a set R is a rule that assigns each element in D to a unique element in R. That's the fancy definition. What's the easier definition? Jacob?
I know it is some sort of line that it can't have repeating x's.
Okay. Can't have repeating x's. Does that sound familiar? Okay. And you'll notice there it talks the values in D cannot repeat, D meaning the domain, right? So I guess if we were, well, we'll get down to it here in a moment, but domain are the x values. And we usually talk about each value in the domain can be mapped or can only go with one value in the range. Okay, so if you have a repeating x value and it goes to two different y values, that makes it not a function. At the beginning of class, I had something on the board. Did you guys get that? This is not I wish I had a functional relationship. Is that what it said? What was it hinting at there? What kind of line was it? It was a vertical line, yes? Remember the vertical line test? Okay, if you're looking at a graph, vertical line test, if you draw a vertical line and it crosses the graph more than once, it's not a function. If it crosses the vertical line just once at a time, then it is a function. Okay, so some things to remember there. So function, big thing is the values in the domain cannot repeat. So that means our x values cannot repeat. When we talk about D, that is standing for domain. The domain is the set of input values, or in other words, the x's. If domain is the input values of the x's, then that means range is the output values or the y's. Okay, easiest way to check and see if something is a function, vertical line test. Okay, if you have a graph, that's the easiest way. Visualize the vertical line. If it touches the graph more than once, it fails the vertical line test. So that is a biggie, and we will talk about that some down our examples. When we get to talking about domain, which I think is down in example 3, some thoughts here to help you along. Okay, so when we talk about finding the domain, so domain is x's, right? Which way do x's go on a graph? X-axis runs left and right, yes? So that means your domain is left and right. How far left and how far right does your graph go? That's what we're talking about domain, is how far to the sides can it go? That's domain. So now it talks about all polynomials have infinite domains. In other words, if a graph is infinitely going up and out or down and out or something, they're going to keep going left and right infinitely. And so we'll talk about some examples where polynomials just have infinite domains. And that's just where you have basic x terms added and subtracted together. And then there's two big things to watch out for. One of which is denominators. If you have a variable in a denominator, what can never happen? Denominators can never equal 0. If you have a variable in a denominator, one of the big things we'll practice is, okay, let's set the denominator equal to 0. What values do I need to exclude from the domain? And so we'll talk about that one, setting the denominator equal to 0 here. And then the other thing, square roots. What do we know about a square root? You can only take the square root of what type of numbers? Positive, right? At least when we're working, I guess I should phrase, at least when we're working in the real number system, right? And that's, unless you're told otherwise, you kind of assume we're working in the real numbers. And so the inside of a square root has to be positive, or in other words, greater than or equal to 0. So square root must be greater than or equal to 0. And that's the basic way of saying it must be positive. Okay? And so we'll set denominators equal to 0 to figure out where excluded values are. And we'll set anything under a square root greater than or equal to 0 to figure out what values we might need to exclude there. Okay? And then it says unless on bottom, in other words, if it's in the denominator, we can't make it equal to 0, only greater than 0. Okay? Let's see, I'm trying to remember what's over here. A couple of things to remember. F of x, if you see an f of x equals, remember that is the same as saying y equals. Okay? Number line, you'll see me referring to the number line to help us figure out domain and range. Okay? Let's see. If a denominator cannot equal something, remember there's going to be a hole there. And we're also going to review using interval notation for our answers. Okay, so we'll go through all of that as we go through these problems. Example 1. Let's start kind of basic. I think once you see it, you'll be okay with it. So example 1. Is y equals x squared a function? Your thoughts, without me guiding you anywhere, because there's a couple different ways we could talk about this.
Yes.
Ethan says yes. You know I'm going to ask you to back that up, right? Why are you saying yes? Okay.
I agree with that.
Vertical line test? Okay, so you guys are looking at the graph, right? And you're thinking vertical line test and it passes, right? So what is y equals x squared the graph of? A parabola, yes? Now, I'll be honest. Y equals x squared, that's one that I would like you to know that, okay, you see y equals x squared, you're like, okay, I know that's going to be a parabola. Okay? So that's, that's a good one to know. And we'll talk about that more in lesson 1.3 that, as you move through pre-calculus and calculus, there are certain things that it's good to know. Okay, y equals x squared. I expect you to know, okay, yeah, that's a parabola. I got it. So if you graphed on the calculators, great. So you've seen what it looks like there. For the benefit of my notes, if I sketch a graph, now, and here's something else to think. Could you also, you guys all went for the graph, which is fine. Could you also think about an XY chart to help you decide if it's a function? Like if I put the x value of 0 in. If my input is 0, what's my output? Well, 0 squared is 0, yes? If I put in 1, what's my output? 1. If I put in 1, 1 squared is 1. What if I put in 2? What do I get? 4. What if I put in negative 1? Get positive 1. What if I put in negative 2? Negative 2 squared is 4. When I'm putting in those x values, can I get more than one y value out? I can't, can I? And so this is kind of an example of, okay, if it's a basic polynomial, which y equals x squared is, it's going to be a function. Because no matter what x value I put in there, I can only get one y value out. And so it's going to be a function. Now, if you graph this, I'm not going to take my time to graph the actual points, but you could, right? You get a parabola that looks like such. And several of you already cited that, hey, it passes a vertical line test. For instance, I drew a vertical line. It only crossed the parabola once. I draw a vertical line. It crosses once. I draw a vertical line. Those are all, I'm showing the vertical line test there. Okay, so vertical line test, think about plugging those values in for x, and can I get more than one value out for y? So, all of this to say, yes, it is a function. Okay. Are we all confident it's a function for one reason or another? You can come to that conclusion on your own. Now, example 1, you had to think a little bit. Example 2 should be pretty easy. I didn't even get to read the question. Dayton's taking my answer. Okay. The question was, which of the following is not a function? Dayton, why are you so quick to say the third one? Okay. It does not pass the vertical line test. If I draw a vertical line, I picked right there, it just touched this function once, twice, 3 times. So that right there says this is not a function because it fails the vertical line test. What about the others? Are they functions? Yeah. If we do vertical lines, they're only going to touch the graph at one point. When you get over here, in our zigzaggy one, same thing, right? It only touches it once. So it just comes down to this one over here that fails the vertical line test. Okay, so we're confident with vertical line test. Okay. Example 3 is where we get to start talking about domain. And it says find the domain of each of these functions. What do I mean domain? Domain are what kind of values? X values. We want to know for what type of X values do these graphs exist. Okay, so A is going to be f of x equals square root of x plus 3. We'll do some work with the equation. We'll also do some work with the graph. But what do you notice in this equation? What do you see that I mentioned up above? Where is the x? In the square root. What do we know about square roots? Square roots must be, see, number 3 up above. Square roots must always be greater than or equal to 0, positive. So right here, do we have a square root? Yeah, we have a square root right here. So we will have to talk about the fact that whatever's under that square root, x plus 3, it has to be positive. Or in other words, it has to be greater than or equal to 0. Okay. And I'm going to pause there. I want to start talking about the problem a little bit. Not done with that problem. Okay. We'll come back and finish it tomorrow and talk about what that answer looks like as an answer. So we'll talk about solving that for x and how to put an interval notation, how it jives with the graph. Okay. Homework, you probably can't do a whole lot of homework yet because we haven't really talked a whole lot about domain and range. So we will pick up on that tomorrow. Okay. And that means there will not be any homework due tomorrow.